All right, so let's balance a redox reaction in a basic solution to round out the balancing of redox reactions. In this process, we're going to do pretty much all the same steps, except in 5b, instead of adding water to both sides to make the reaction physically meaningful, we're going to add hydroxide to both sides to make sure it's a basic solution. So we're going to start out in the same way by assigning oxidation numbers to all of the elements. Here, if we have hydrogen, each hydrogen is +1. I have 4 of them for a total of +4, which means the nitrogens have to be -4 in total. Well, there are 2 nitrogens, so each nitrogen is going to be -2. For the oxygen is -2 each times 3. The oxygens account for -6 charge. -6 plus 5 is what's going to equal the -1 charge on the polyatomic ion. Here, oxygen is -2, which means nitrogen has to be +2. And over here, chlorine is just a monoatomic ion, so that's -1. Now we can connect our reactants and products with the tie lines in order to determine what's oxidized and what's reduced. So here's nitrogen. Nitrogen goes from a -2 to a +2, which means it's being oxidized. So we'll put oil on there. And then chlorine is going from +5 to -1. So we'll put a rig there. It's being reduced. It's gaining electrons. Okay, so that's step 1. And step 2, we're going to split this up just like we did before. Step 2, we're going to take the oxidation half reaction first, just like we did before. And so here the oxidation half reaction is N2H4 reacts to form NO. Again, you can wait until the very end to make sure you have the phases. It won't hurt you to do that. In step 3, we're going to balance everything except hydrogen and oxygen. Okay, so when we balance everything except hydrogen and oxygen, it's really simple. I've got 2 nitrogens on the reactant side. I need to get 2 nitrogens on the product side, so I'll put a stoichiometric coefficient of 2 there. So N2H4 reacts now to form 2NO. Step 4, we're going to balance oxygen. And so we're going to do that by adding water to the side that needs oxygens. So over on the product side, we have 2 oxygens, but none on the reactant side, which means I need to add 2 waters to the reactant side in order to balance the oxygen. Then step 5, we balance hydrogen. And in 5a, remember we add hydronium to each side for each one that we need. So here I've got 2 times 2 is 4 hydrogens on the reactant side, plus another 4 on the reactant side. So I've got a total of 8 hydrogens on the reactant side and none on the product side. So I'm going to have to add 8 hydroniums to the product side. So 2H2O plus N2H4 reacts to form 2NO plus 8H+. Now in step 5b, this is where we have to figure out how many hydroxides we add. Remember, it's based on the number of hydronium ions here. So what I need to do is, if I have 8 hydroniums, I have to add 8 hydroxides to each side. Okay, now when I combine these, I'm going to get 2H2O plus 8OH minus plus N2H4 on my reactant side, and then I'll have 2 nitrogen monoxides on my product side, plus remember, when I combine these, that gives me 8 H2Os, right? H plus and OH minus. Each pair gives me a water. So that'll be plus 8 H2O on that side. Step 6, This is where we balance charges. No charge for the water. I've got 8 times -1 gives me a -8 for the hydroxides and no charge there. On the other side, I've got no charge for the nitrogen monoxide and no charge for the water, which means I need 8 electrons and they go on the more positive side. So now I'm going to rewrite this with my electrons in here. I've got 2 H2O plus 8 OH minus plus N2H4 react to form 2 NO plus 8 H2O, and here are my 8 electrons, plus 8 electrons. Remember, if you have an oxidation half reaction, the electrons are always going to be on the product side. Now, as we go into our next slide, we're going to go back to step 2, but this time for the reduction half reaction. And the reduction half reaction, remember, if we go up to this equation, we figured out is chlorate reacting to form chloride. So we'll do step 2. ClO3 minus reacts to form Cl minus. Okay, so we start again with step 3, balance everything else. Other than H and O. So we'll do that over here. I'm going to shift my arrows over. So we have everything else balanced, right? I've got 1 chlorine on each side. ClO3 minus reacts to form Cl minus. Next part, 4, we're going to balance oxygen. We do that again by adding an oxygen to each side for what we need. And so on this one, if I have 3 oxygens on my reactant side and I have none on my product side, I need to add 3 oxygens to the product side. Oop. Try that again. That should be 3 H2Os. Okay, so I had 1 water for each oxygen that I need, and that's going to be on the product side. And in step 5, I'm going to balance hydrogen. Okay, so 5A, I got to figure out how many hydrogens do I need, how many hydronium ions do I need. So 3 times 2 hydrogen, that gives me 6 hydrogens on the product side and none on the reactant side, which means I need to add 6H plus to my reactant side, plus ClO3 minus reacts to form Cl minus plus 3H2O. Okay, so on to 5B. Remember, this is a basic solution. And so for 5B, we're adding a hydroxide to each side for every H plus. So here I've got plus 6OH minus, and over here we'll have plus 6OH minus. On the reactant side, they combine, so I get 6H2O plus ClO3 minus reacts to form Cl minus plus 3H2O plus 6OH minus. Now here's a place where you may simplify if you really want to. Notice, and I'll switch colors for this just so you can really see it. Notice that I have 3 waters here and I've got 6 over here. I can, if I want to just simplify that part now, I can do that. So I'm going to get rid of those 3 waters. I'm going to turn that 6 into a 3. And I'm going to simplify now before I get to step 6 in balancing the charges. So now I should have 3 H2O plus ClO3 minus reacts to form Cl minus plus 6OH minus. So that's one of those keys here is you can balance as you go through, and that's fine if you're just subtracting off superfluent molecules or ions. That's okay. That shouldn't cause any problems. Next thing, we've got 3H2O plus ClO3 minus reacts to form 6OH minus. So we got to figure out charges. So I've got 0. I've got 1 times -1 gives me -1 total on the reactant side. On the product side, I have 1 times -1 gives me -1. And then 6 times -1 gives me -6 for a total of -7, which has a difference of 6 electrons that go onto the more positive side over there. So here I should have 6 electrons plus 3 water plus chlorate react to form chloride plus 6 hydroxides. And so that should be my balanced half reaction for the reduction half reaction. Now remember the next step, we're going to use that lowest common multiple to figure out how many of each of these we need. What do I have to multiply this equation by and the other equation by? So I've got a 6 and I've got an 8 electrons. Well, in order to get 6 and 8 to be the same thing, the lowest common multiple for 6 and 8, well, that's going to be 24. And so I have to multiply the reduction half reaction by 4 and the oxidation half reaction by 3. So what we'll do, we'll multiply this by 3. We'll go set this up. So we have our step 7, our oxidation half reaction. Okay, and we'll go and start by going to our oxidation half reaction. We've got 3 times 2 waters, 3 times 8 hydroxides, and 3 times 2 dinitrogen tetrahydrides. So I've got 6 waters, 6 OH minuses, and 3 NH2s. Okay. 8 times 3, so that's liquid, plus 24 OH minus, plus 3 NH2, excuse me, N2H4, do this right, reacts to form. Here, let me clean that up a little bit. Make sure that's nice and easy to read. Plus 3 N2H4, and that should be a gas. Reacts to form. We've got 6 NOs, 24 waters, and 8 and 24 electrons. Okay, now for a reduction half reaction. Okay, for a reduction half reaction, we should have, so 4 times 6, so 24 electrons, 12 waters, and 4 chlorates. And those react to form, again, we're going to go back here, 4 chlorides and 24 hydroxides. Okay, so let's put these together, but let's simplify this a little bit first. All right, so we'll start with blue. Let's get rid of our electrons. 24 electrons and 24 electrons if I did this properly. And we'll go to green. So let's look at waters. I've got 6 waters on the reactant side here and another 24 on the product side here. So this I can actually already change to 18 and get rid of these ones. I could have done that in a step before. Now I've got 12 waters here and 18 over here, so I can get rid of those 12 and change my 18 now to 6. So there are 6 waters there. Then I'll go to purple, we'll do our hydroxides. I've got 24 hydroxides here and 24 hydroxides here. And that looks like those are all the ones that I can get rid of. So notice, even the hydroxides, they cancel themselves out here, and that's okay. That'll occasionally happen. So we'll start with my reactants from my oxidation half reaction. I've gotten rid of my waters and my hydroxide, so I'm left with 3 dinitrogen tetrahydrides. Then I've got my reactants from my reduction half reaction. I've got 4 chlorates. Okay, those are aqueous. Those will react to form my products. So I'll start up with my oxidation half reaction products. It'll be 6 nitrogen monoxide gas plus 6 waters, liquid, plus, then I go to my products on my reduction half reaction, 4 chlorides. Okay, so that should be balanced. I've got 3s and 4s in here, so I can't reduce those stoichiometric coefficients more, but I can. So if that was step 8 where I combined them, step 9 is to check. So I've got nitrogen, I've got chlorine, I've got hydrogen, and I've got oxygen. So the nitrogen, I've got 2 times 3 is 6. The other side, the nitrogen, I've got 6 times 1 is 6. If I go to the chlorines now, I got 4 times 1 on the one side, so there's 4. And 4 times 1 on the other side is 4. Hydrogens, I've got 3 times 4 is 12. And I've got 6 times 2 is also 12. And then for oxygen, I've got 4 times 3 is 12. And on the other side, I've got 6 times 1 plus 6 times 1. That gives me another 12 oxygens. Looks like I'm balanced, and I have my equation here. And one of the things that you've probably noticed that I've done is every time I've done a new step, I've written out the entire equation. That's one way to keep yourself organized. Now, you don't have to do it exactly that way. If you have color-coded, like if you have colored pens, a good way to do it is color code each step. So that's each of these 2 examples, one of an acidic solution redox reaction and one of a basic solution redox reaction will be balanced using the half reaction method. So hopefully this has been of help to you, and you'll get some good practice doing the lab and the worksheets that are there. So you can really be able to balance these reactions. Although tedious, it should get you to the right place each time. So good luck. Don't forget to come into office hours and ask questions when you need to, and I'll see you then.